Welcome to Bot Thoughts by AmtocSoft. I am Alex, and today we are talking about a pattern that sounds small but changes how production agents are operated: context packets. If your agent prompt has become a junk drawer of policy text, retrieved documents, tool instructions, examples, incident fixes, and one-off reminders, this episode is for you. The question is simple. When an agent acts, can you reconstruct what it actually knew?
Exactly. A lot of teams start with a single giant prompt because it feels flexible. Then the system grows, retrieval gets added, tool calling gets added, safety policies get added. A few production incidents happen, and suddenly the prompt is not a prompt anymore. It is a compressed operating manual with no schema, no owner, and no replay boundary.
Let me push on that. If the model is getting the right text, why should engineers care whether it arrives as a tidy packet or as one big rendered prompt? The model sees tokens either way.
Because tokens are not a contract, they are the final rendering. A context packet is the structured object before rendering: task frame, stable core, evidence slice, action budget, output contract, and replay envelope. You can log it, diff it, cache it, test it, and ask who owns each part. A raw prompt blob gives you text. A packet gives you an operational boundary.
So imagine a support agent refunds an account it should not have touched. The incident review asks what happened. Without a packet, the team digs through logs and sees a giant prompt with some docs in it. With a packet, they can ask, what policy version was active, what customer records were retrieved, what tool budget was granted, and what trace id tied the decision together.
That is the shape. I usually describe a packet as 6 fields. First, the task frame. What job is the agent doing right now? Second, the stable core, the durable rules that do not change every request. Third, evidence, retrieved documents, database rows, summaries, and citations. Fourth, action budget, which tools are available with what limits. Fifth, output contract, the schema or response requirements. Sixth, replay envelope. Model id, prompt template version, retrieval config, timestamps, and trace ids.
That sounds neat, but also a little enterprise-wide. Is this something only big companies need? Or does a small team building a two-tool agent benefit too?
Small teams may benefit first because they do not have spare people to debug vague failures. The packet can be a simple JSON object. It does not need a platform team or a governance committee. Even 3 fields can help: task, evidence, and allowed actions. The point is not bureaucracy. The point is being able to say, for this exact model call, here is the input state we intentionally assembled.
Give me a concrete example. Suppose we have an internal engineering assistant that can read runbooks, query recent incidents, and draft a remediation plan. What would the packet look like?
The task frame might say, explain why checkout latency rose and propose a rollback plan. The stable core says, do not execute changes, use incident language, cite evidence, and separate observation from recommendation. The evidence slice includes the last deploy, 3 traces, 2 dashboard summaries, and the relevant runbook section. The action budget says, read-only access to logs and traces, no deploy tool, no ticket closure. The output contract asks for symptoms, likely cause, confidence, and next checks. The replay envelope captures versions and trace ids.
You mentioned caching earlier. People usually talk about context engineering as a quality problem, but there is a cost angle too, right?
Right, stable instructions and volatile evidence behave differently. If you mix them into one string every time, the system cannot reason cleanly about reuse. If the stable core is versioned separately, you can cache it, evaluate it, and roll it forward on purpose. The evidence slice changes request by request. The packet boundary lets you measure which part is expensive, which part is stale, and which part actually influenced the answer.
Security folks are probably leaning forward now, because the phrase evidence slice is where prompt injection usually sneaks in. How does a packet help there?
It helps by making untrusted material visible as untrusted material. A bad product review, PDF, web page, or support ticket can still contain hostile instructions. The packet should label that content as evidence, not policy. The stable core can say evidence may describe the world but cannot override tool permissions. The action budget can be enforced outside the model. That last part matters. Do not rely on the model to remember a permission boundary written in prose.
That line feels important. Do not bury tool permission in prose. If the model can call tools, the action budget should be a field, logged and checked before any call.
Exactly. A packet can say the agent may read invoices but not issue refunds, may summarize tickets but not close them, may propose a database migration but not run it. Then the tool layer enforces that budget. The model should not be the only guard. The packet tells the model the rules, and the runtime verifies the rules.
What is the non-obvious failure mode you have seen with this pattern? Because every useful pattern has one.
The common gotcha is building a beautiful packet and then rendering it into a messy prompt that loses the boundaries. The JSON looks clean in the logs, but the final prompt says, here are some rules and here are some documents, all in the same style. The model has no strong cue that one block is policy and another is untrusted evidence. The renderer matters. Use headings, delimiters, source labels, and explicit priority order.
So the packet is not the end. You still need a prompt renderer that preserves meaning. That is almost like compiling a typed object into a text protocol.
That is a good analogy. Treat the rendered prompt as a compiled artifact. Engineers would not casually concatenate source files and hope a compiler understands intent. Yet with agents, teams concatenate policy, examples, retrieve text, and tool docs all the time. A renderer should be deterministic, tested, and versioned. If packet version 1.4 renders differently from version 1.5, that should be visible in evaluation runs.
Let us talk evaluation. How do packets make evals better than the usual spreadsheet of prompts and expected answers?
They let you test the actual operating surface. Instead of only testing final text, you can test packet construction. Did retrieval include the right evidence? Did it exclude stale docs? Did the action budget match the user role? Did the output contract request the right fields? Then you test rendering, model behavior, and tool enforcement separately. That separation helps you find the fault line when something regresses.
That is a big deal for debugging. Without separation, every failure becomes model did something weird. With separation, you can say retrieval was wrong, policy was stale, action budget was too broad, or the renderer blurred the boundary.
Yes, the phrase model did something weird is often a symptom of missing instrumentation. Sometimes the model did exactly what the assembled context implied. The bug was upstream. A packet gives you checkpoints. Packet built, packet rendered, model called, tool requested, tool authorized, output validated. Each checkpoint can emit a trace event. That makes agent debugging feel more like distributed systems debugging and less like reading tea leaves.
Since you said traces, how would you connect packets to OpenTelemetry, or whatever observability stack a team already has?
Do not dump the whole packet into every span. That creates privacy and cost problems. Instead, record stable identifiers and safe summaries. Packet schema version, policy version, retrieval corpus names, evidence IDs, model ID, tool budget name, output schema version, and redacted counts. Store sensitive packet contents in a controlled log or artifact store with retention rules. The trace should point to the packet, not spray it everywhere.
That privacy point matters. If the packet includes customer data, medical notes, contracts, or internal tickets, the observability layer cannot become a second data leak.
Correct. A packet boundary makes privacy review easier because you know where sensitive inputs gather. You can redact at the boundary, classify fields, enforce retention, and prevent accidental copying into analytics. If everything is one prompt string, privacy review becomes a scavenger hunt. Structured packets give security and compliance teams something concrete to inspect.
Here is the skeptic version. Are we just rebuilding request objects? Backend engineers have been passing structured inputs around forever. Why does this need a new name?
Fair pushback. The novelty is not that JSON exists. The novelty is that language model systems often skip the contract at the exact point where ambiguity is most expensive. A context packet is a request object designed for probabilistic reasoning plus tool use. It carries evidence priority, trust boundaries, action limits, output contracts, and replay metadata. Traditional request objects rarely need to explain which text is authoritative and which text is untrusted.
How should a team adopt this without pausing all feature work for a giant platform rewrite?
Start at the highest risk boundary. Pick one agent action that would be painful to explain after the fact. Refunding, changing access, modifying a ticket, sending a customer email, opening a pull request. Build a packet for that action only. Log the packet id, policy version, evidence ids, and tool budget. Then add one eval suite that replays 10 real or synthetic packets through the renderer and model. Keep it boring.
What metrics tell you the packet is actually helping and not just adding ceremony?
Track replay success rate. Can you reconstruct a prior decision from logs and artifacts? Track context size by field. Stable core tokens, evidence tokens, tool docs, output contract. Track tool denials by budget. Track retrieval misses. Track incident review time. Also track evaluation failure category. If failures move from mysterious model behavior to specific packet construction defects, the system is getting easier to operate.
Let us list the mistakes. First, putting everything in one text field called context. Second, saying the action budget in prose but not enforcing it. Third, logging sensitive packet contents everywhere. What else?
Fourth, letting every feature team invent a different packet schema. Fifth, failing to version the renderer. Sixth, treating examples as policy. Seventh, not recording retrieval configuration so replay cannot reproduce the evidence slice. Eighth, assuming longer context solves packet hygiene. A million token window can hold a messy room. It does not clean the room for you.
My takeaways are these. A context packet is the structured handoff before the prompt. It separates stable instructions from volatile evidence. It makes action permissions explicit. It gives observability and security teams a real artifact to inspect. And it makes replay possible when something goes wrong.
And the next thing to learn is how packets connect to evaluation and authorization. Once your context has a boundary, you can test whether the right evidence entered, whether the right tools were allowed, and whether the final answer obeyed the output contract. That is where agent engineering starts to look like serious software engineering.
Before we wrap, I want to go one layer more practical. If somebody opens their editor after this episode, what fields should they actually put in a first packet schema? Not the forever architecture, just the first useful version.
I would start with a small schema and resist the urge to model the universe. Use requested, user intent, actor role, policy version, evidence items, allowed tools, denied tools, output schema, model profile, and replay metadata. Evidence items should have source, trust level, retrieved at, citation id, and summary. Allowed tools should have name, scope, limit, and reason. Replay metadata should include packet version, renderer version, retrieval config ID, and trace id. That is enough to make the next incident review dramatically less vague.
Versioning keeps coming up. I think teams sometimes hear versioning and imagine a lot of process. But for packets, it sounds more like the minimum needed to know whether two agent calls were meaningfully comparable.
That is the right framing. If the policy text changed, the renderer changed, the retrieval filter changed, or the output schema changed, then the agent call changed. You do not need a heavy release ceremony for every edit, but you do need identifiers. Otherwise, a regression from Tuesday and a success from Wednesday look like the same experiment when they were not. In model systems, that false comparison is poison. It leads teams to blame the model, or the user, or randomness, when the actual change was a silent context mutation.
Where does human review fit? A lot of production agents still have humans in the loop for higher-risk actions. Does the packet help the reviewer, or is it only for engineers after the fact?
It helps the reviewer if you design for it. A reviewer does not want the whole prompt. They want the short packet summary, task, risk level, evidence, proposed action, missing information, and reason code. If the agent wants to send a customer email, show the reviewer which policy drove the language and which source records were used. If the agent wants to open a pull request, show the files, tests, failing signal, and rollback plan. The packet becomes the reviewer brief.
What about model routing? We have talked before about sending cheap tasks to smaller models and harder tasks to stronger models. Does the packet make that cleaner?
Very much. Routing should not be based only on prompt length. A packet can expose risk level, required tools, evidence complexity, data sensitivity, and output strictness. A low-risk summarization with no tools might go to a small, fast model. A high-risk action with customer impact, ambiguous evidence, and strict output requirements might go to a stronger model or require human review. The router can make a policy decision using packet fields before any model sees the text.
Here is another anti-pattern I have seen. Teams add more retrieval every time the agent fails. It answered wrong, so they give it more documents. It missed nuance, so they add more examples. Eventually, the model has too much context and still no clear job.
Yes, and packets make that visible. If evidence items grows from 5 concise records to 80 mixed records, you can see the bloat. You can measure evidence precision. You can ask whether the agent needed raw documents, short summaries, or just citations. More context can make a model sound more confident while making the decision path harder to reconstruct. The packet pushes teams to ask which evidence belongs in the decision, not merely how much fits in the window.
There is an organizational point hiding here too. Who owns the packet? Is it the application team, the platform team, security, or whoever wrote the first prompt?
Ownership should be split but explicit. The application team owns the task frame and output contract because they understand the user workflow. Security owns or approves trust boundaries and action budgets for sensitive tools. Platform owns reusable schema conventions, renderer libraries, tracing hooks, and evaluation harnesses. Domain experts own policy content. The dangerous version is nobody owns it. So the packet quietly becomes a place where every group hides a requirement and no group tests the combined behavior.
If I were rolling this out next week, I would choose one agent, one risky action, one packet schema, and one replay test. Then I would run the old prompt and the packet-rendered prompt side by side for a few days before changing production behavior.
That is the right amount of ambition. Shadow mode is useful here. Build packets for real traffic, render them, maybe even score them, but do not let the new path take action yet. Compare output quality, tool requests, refusal behavior, and review burden. Then roll out by action type. Start with read-only advice, move to draft actions, then gated execution, and only then consider autonomous execution for low-risk paths. Packets are an enabling layer, not a reason to skip rollout discipline.
That framing is useful. Packets do not make agents safe by magic. They make agent behavior more inspectable, testable, and governable. That is less glamorous than a new model demo, but it is the kind of thing that decides whether an agent survives contact with production.
Exactly, the industry keeps oscillating between magic and fear. Context packets are neither, they are plumbing. Good plumbing lets higher-level systems work without flooding the building. For production agents, the packet is where intent, evidence, authority, and accountability meet. If that boundary is sloppy, everything downstream becomes harder to trust.
Let me turn that into a checklist listeners can steal. First, name the action. Second, mark the evidence as trusted, untrusted, or derived. Third, make the allowed tools explicit. Fourth, record the policy and renderer versions. Fifth, keep enough metadata to replay the decision later. If those 5 things are missing, the agent may still work, but the team is operating it partly by memory.
And I would add one final test. Hand the packet record to an engineer who did not build the feature and ask them what happened. If they can explain the agent's task, evidence, authority, and output without opening 5 dashboards and guessing, you are on the right path. If they cannot, improve the packet before adding more model complexity. The goal is not a perfect schema. The goal is a system that can explain itself well enough for humans to operate it.
That is it for this episode of Bot Thoughts by AmtocSoft. The companion article is Context Packets for Production Agents. Keep the models small, auditable, and fast. Subscribe on YouTube and Spotify, and if this work helps you, you can support it at buymecoffee.com/AmtocSoft. Share it with the engineer who owns your first production agent review this quarter. Next time, we will keep following the production agent thread and talk about what teams should measure before trusting autonomous workflows in real customer-facing production systems.